Hi everyone, welcome today. So today we'll be doing vector components. So what we'll be doing basically, continuing from our lecture, is we'll be doing breaking down each and every vector into components. So in this series, we are only going to be looking at two components. So we're just going to be looking at the y and the x. We are not going to look at the z component. So we're breaking down into an x and a y component. So I have in a way shown you this, but without necessarily mentioning it. And just to point out something, we are using for instance, the unit vector that we are using is the y and the x. Now you will see some textbooks. In some textbooks they use the I and the k, an I and a j, not a k. Right, so they will use like an I and a j. So when they write a vector, you see like a vector maybe it's like 3i plus maybe like 4j. So this is the same thing as someone writing a vector and say a vector is 3x plus like 4y. Right, now don't worry about this, it will make sense once we finish everything. It's just to make you aware that some books they actually use I and j. I prefer to use x and y. So when you go through a textbook and a textbook is using a different notation, don't get confused, it's still the same thing. Alright, okay, so that's fine. Let me try and erase that. And then alright, so in this section we'll just be breaking down vectors into components. So I'll show you almost everything, hopefully. It should be everything that you need to go by to just break down any type of vector. Alright, so let me say for instance let's start with a vector that is very simple to break, and this is a vector that is in this direction. Let's call this vector vector A. So let's say that this vector has an angle of theta. That's the direction of the vector, whatever the angle is, right? So this vector, you can actually break it down into components. So when you break the vector down into components, you must always do it like this. You must always start at the tail. So start at the tail. Never start somewhere, just always start at the tail. So you can see that the head is somewhere here. So you want to go towards the direction of the head. So the head is this side. It's on the right hand side, right? But then you don't want to go straight to the head. You want to go via a long route, if you may think about it. Rather than going from here to here, you want to go the other way around. You want to go like x to y, or sometimes it's y and x. So you want to take a long route. Think of it like that. So how would you do that? Well, the easiest way to get to the head for this one, well, it's not the easiest way, but one of the ways that you can get using the x and the y is I can go that way. Okay, so you stop. I mean, if I was to draw a line like this, so I would have to stop somewhere here, right? So when I stop somewhere here, then yeah, I can see the head now. So I stop, right? Then I stop here. Then I go from here. Now you must now join it from the vector that you just drew. Now go up, right? So you just want to go left or right, up or down, right? And then you go up. So let's use a different color. So if you use a different color and then you go up, you are going up, and then voila, you managed to get to the head, right? So you will notice that you have basically drawn two vectors. So if this is vector, remember that if you have a Cartesian plane, if there was a Cartesian plane here, now left and right is going to be the x direction, and up and down is going to be the y direction. If you had a Cartesian plane, it's going to be the y direction, and then this one is going to be the x direction. So which means that this one is actually something that we call the x component of this vector, meaning that it's something that is part of this vector, but it is in the x direction, right? It's still part of this vector. It's not the whole vector. Something that is part of this vector, but in the x direction, right? And it is still a vector. So this line, this blue line, is still a vector. Then this thing, the line that is going up, is still a vector as well, but then it's in the y direction. I mean, it's going up. So anything that is going up or just going straight down, it's in the y direction. Anything that is going to the right or going to the left is in the x direction, because remember the Cartesian plane, right? It's x, and then this one is negative x, so left and right. So up and down is anything up and down is y, anything here is negative y. These are just the directions. Remember the unit vector? I'm using unit vectors. These are just vectors that are just pointing out the direction. They have a magnitude of 1. I explained that. Alright, now also you will notice from our previous lecture that this looks very similar to what we did. So you'll notice that this vector A is actually from the tail of this blue line vector, which is the first vector, to the head of this y vector. Now, in the previous lecture, when we said, look, I mean, if I'm adding a vector and I say it's ax plus ay, how will that vector look like, right? So I would draw ax in that way, then I would draw ay that way. So whatever that I'm adding, it will start from here to here. That vector is going to be the resultant vector of these two vectors. So it looks exactly like A. So it means that this A actually is the resultant vector of these two vectors. Therefore, what you have effectively done is you have actually managed to break down the vector A into different components. Right? So this is what we mean when we say that you are actually resolving vector A into x and a y component. Right? Now, how can you find the magnitude, for instance? Well, remember in trigonometry, this is a right angle triangle, there's an angle, right? If you look at this diagram here, if I take the cos of theta, for instance, if I take the cos of theta, what would the cos of theta be? The cos of theta would be the magnitude of ax divided by whatever the magnitude of a is. So I can find ax. If I know a, it's going to be, I cross multiply these two, take this, multiply it here, then I end up with a cos of theta. So that's how I can find whatever the value, like the magnitude, the size of a. So normally you'll be given a, and then you'll be asked to find these other sides. Alright. And then how about the y component? How can I find the y component? If you take the sine theta, I mean from trigonometry, if you look at this triangle, right angle triangle, take the sine of theta, you can see that ay is going to be this. So it means that I can find ay if I make ay the substitutable formula is going to be a sine of theta. So it doesn't matter what this vector is, and I'll do it for different directions, different positions for theta, and so that you can actually know how to figure it out. Alright, so it doesn't matter what they write, even if they call this vector v, even if they call it b, it doesn't matter what they call it. It shouldn't confuse you. What you should look at is the pattern. If you just say this is the vector, I want to get to the head of the vector, but using the x and the y root. So how will I do? I'll start with the x and then go with the y. Now it's not always the case where you start with the x. So I'll do another example now where you can actually start the other way around. Alright, so let's look at that example. Okay, so let me say for instance, I still have the Cartesian plane, but now I have the vector going that way. Now let's call this vector b because we don't want to confuse it with that vector. Let me just take it back, and then one more time. Let me write b here, and I have a reason why I want to write b there. Then there's my Cartesian plane. Alright, now the question is, how can I get to this head? Now if I tell you that the angle theta is somewhere here, because the question can be given to you such that theta is now here. Right, so it's forcing you to use a different way to get to the head here. So you're still starting here. So you must always start here. So how can I get there? Well, I can go up first. See, I can't just go to the right first because I want to use this theta. If you go to the right, to the left, you're not going to be able to use this theta. So you must go up first. Alright, so I must go up first. There, I must go up first, then just about it. So you just measure and see. You can draw this line, an imaginary line if you want, but with experience you can just measure where you should stop. Right, you want to stop about somewhere around this line. Right, but you haven't got to the head yet. right? So you still need to go to the head. So to go to the head is you join another vector from the tail of this, and then that vector will get you to the head. Now if you look at this, this is now by, so this is the component that is in the y, this is the component of b in the y direction, and then this is bx, which is the component of b in the x direction. Remember, anything going left or right is still in the x direction. Alright, now the question is, okay, so how will I find bx and by? Now you see it's different from this one, from the one that we did before. Now this one, you must always look at where the angle is. So if you look at this angle, if we draw a straight line, just opposite that angle is the bx side. And remember what we're saying that sine of theta will be given by whatever is opposite the angle over the hypotenuse. Right, that's a definition of sine theta. Definition of cos theta is that it is the adjacent side over the hypotenuse. Right, the longest side. This is the longest side of the right angle triangle. There's the right angle here. So it's still a right angle triangle, it's just that it's awkward. It is looking like this. So it's not something that you guys are used to. So it's still a right angle triangle, just that it looks like this. This is your hypotenuse here. And if this is your angle, this is your adjacent side. And this is your opposite. This is the side that is opposite the angle. That's why I drew this line. I mean, this side is opposite the angle. So this is how it is. Alright, so which means that if I want the side that is opposite the angle, I must use sine. So for this one, sine of theta will be bx in this time around over b. Then for this one, this would be by over b. Right, so remember I'm just using magnitudes here. So which means that if I want bx would be given by a sine of theta, and by will be given by a cos of theta. So you don't cram. It's not all the time whereby the x component is going to be cos, and all the time where the y component is going to be sine. Right? It's not always the case. Alright? So this is how you can actually find what is the magnitude of that. Now let's see, how can I represent these vectors? Right? How can I represent them using the x and the y? Alright? And maybe I will just make an example, a simple example, right? Okay, so I'll start with the simple case and then we'll just build on that. The simple case being, let's use the same vector a, but now let's give it a magnitude. Let's say a is 5, and I'm telling you that this one is 3, let's call it 3, whatever 3 units, whatever it is. Then the y component is going to be 4 units. Alright, and then I'm going to have theta here. So I can find everything. Right? So if I want to represent this vector A is going to be a sum of vector AX plus the sum of vector AY, because this is AX, and then this one is AY. Right? I've just given you the magnitudes. Alright? So how can I write this? Well, A is going to be the magnitude of AX. So in this case, the magnitude of AX is 3. What is the direction of AX? It is going in the positive direction, because I'm always choosing my X direction that way positive, my Y positive going up. So it is going in the positive direction, it's going to the right, so it's going to be X like this. Then let's see, what about the Y? The Y is going up, so it's going to be plus here. And then the magnitude of AY is basically 4, and then the direction of AY is that. Right? So this is how sometimes a vector could be. So a question can actually give you a vector like this. This is a vector. So when they've given you a question like this, what you should do is you should draw a vector. It's 3 in the right direction, then it is 4 going up. They are telling you that the vector A is going to start from the first vector to the last vector, to the head of the last vector, you draw a line, and then that's going to be that vector. So they've actually given you AX and AY. Right? That's basically how. So you could be given a vector like this, or you could be given a vector in a statement. Like they can say to you, vector A is whatever magnitude, whatever the degree or the angle is, maybe like north of east, for instance, and then this would be the case here. So it would be different. So you could get, so when you have done this, you have actually broken down the vector A into components. So this is still a vector. You are representing vector A in terms of its components. All right. Okay. Now, let's just do a general case and same vector. But now I'm not going to give it the value so that you just know what is the general case. So if I have the same vector, has the angle theta. Alright, it's the same vector, it has the angle theta. If I draw a vector in this direction, this is AX. Now we all know, we all agree. If I draw another vector in that direction, this is AY. We now all know this and we have accepted this. So if I want the magnitude, this is the right angle triangle. So if I want the magnitude of A, the magnitude of A will be given by AX squared plus AY squared. So which means that I must know what is AX and I must know what is AY. Alright? And then if I wanted the direction theta, it would just be given by that, which is AY over AX. Okay? So we have done this in the previous lecture, or if you just look at the lecture before this lecture, and then you will see how we actually did it. So let me represent, you remember what I've said? I said if it's like this, the magnitude of AX is going to be A cos of theta, and the magnitude of AY is going to be A sine of theta. So if I want to write the vector A, the vector A is the sum of these two vectors. How do I know? Because from the tail of the first vector to the head of the second vector, therefore it's a sum. If you look at AX and AY, they are joining from head to tail, right? So it's tail to head, so you're joining them from tail to head. From tail to head, and then tail to head. That's how you are joining them. So once you do that, you are adding those vectors. That's how you are geometrically adding them. Okay? So, which means that the vector A is going to be, the x component is going to be made up of the x component and the y component. So these are still vectors. So I haven't factored in directions. So if you want to work this out further to simplify it, then you'll say, well, AX, I don't know what the magnitude of AX is. So it's going to be AX. But I can see from my diagram that is going in the positive x direction, so this is the positive x direction. And then plus, which is this plus here. What about AY? AY, do I know the magnitude? I don't know the magnitude, so it's AY. Do I know the direction? Yes, it's going on the positive. Remember, a vector is always something with magnitude and then plus direction. So when you write it, there must be a magnitude, which is this part, and the direction, which is this part. Magnitude, which is this part, and the direction, which is this part. Alright? Now I can break this further, and I say the vector A, if I was asked to calculate it, then the vector A would be, I said AX is going to be this, so I can substitute A cos of theta here, and the direction would be X. So this is the magnitude, and then I can substitute A sine of theta here, and the direction is this. So don't worry, we're going to do an example that is going to break everything down. I'm just showing you and teaching you how you can actually view these things in different ways, and how they can be written so that you are not confused when they are written. Alright? So this is when the vector is like this. Remember, if a vector maybe is like this and the angle is here, this will change. It depends on the angle, right? Let me just do it when it's facing down. I'll just do one example when it's facing down so that you can see us also, so that you can see that as well and you don't get confused. What happens, for instance, if I have a vector that is going, let's make it interesting, let's make it go negative and negative, right? So what happens if I have a vector that is actually facing this way, right? Let's call this vector B. Now if I draw a Cartesian plane on the tail, you can see. So what happens if I say to you the angle is somewhere here? So let's look at this. How can we get to the head? We'll have to go down. There we are going down. Then we'll have to, from here, go to the left like that. All right. Now this one is going to be B, Y, and this one is going to be BX, and these are vectors because I'm not representing a magnitude. So how can I write this vector B? This vector B is the sum of the x component. It's always the case. It's always the sum of the x component plus the y component. It's always the case. It's always the sum of the two. Alright, so that's fine. Then what you then do after that is break it down. If you look at this one, do you know the magnitude of bx? There's bx. Remember, you always choose this side to be positive. And then you choose this side to be positive, which means that anything going this way is going to be negative. Anything going down is going to be negative. So let's look at this now. If you look at bx is going that way, to the left. So it's going to be negative. Do I know the magnitude of bx? I don't know it. I don't know how big bx is. But then I do know the direction. The direction is going to be negative x because it's going that way. Now what about by? Well, by is going to be, do I know the magnitude of by? I don't know the magnitude of by, right? Chances are you could calculate it, but then even if you can calculate it, don't assume you know it. Just pretend like I still don't know it, I haven't calculated it yet, so I don't know it. But okay, by is going down. So I don't know its magnitude, but I know it's going down on the y. So it's also going to be negative. Alright, so which means that this vector B is going to be whatever B is. I can take out the negative and then I can say it's bx in the x direction. Then this negative is going to come out, and then you multiply this positive with this negative, you get a negative. Then you are left with by in the y direction. Alright, so this vector is negative, negative. So it depends. Now let's see. How will I find bx and by? Look at the angle. If you draw a line here, the side that is opposite that angle is bx. So which means that bx is going to be b sine. We are going to use sine because it's opposite. Whenever it's opposite, use sine. Whenever a side that you're looking at is adjacent, meaning that it's just next to, just use cos. That's how you can cram them if you want to cram them. Right, but then if you want to understand them, you just understand them in that fashion, right? Whatever is next to, and then remember we use the trigonometric definition of what sine theta is and what cos theta is. Sorry about that. Okay, so you could maybe, if you knew the number, so sometimes you'll be given the value of b and you'll be given the angle, and then they'll be asking you maybe to just break down this vector into components. So you could find what is the magnitude of bx, which is going to be b sine of theta. So you would know this value, substitute it, and then find it. And then minus this one would be b cos of theta. Substitute this value, substitute that value, and it's in the y direction. Then you'll get your vector. Alright. Now how about vectors that are straight? You just have a vector that is on the x and it's on the y. What does it? Can I break it down into x component and y component? Yeah, sure, you can. So you can write any vector into x and y, right? So let's just do the easy one. Let's do the one that is in the x direction. Let me say I have a vector and my vector is in the x direction. All right, there's my vector. It's in the x direction. So this is y. So this is x. Let's call this vector a. All right. So if I call this vector vector a, this is the y, right? If I call this vector a, all right? So let's look at it. How can I get to the head of this vector? So I'll use a green line for that. I want to move from the tail to the head going the horizontal and the vertical way. So I move from the tail of the vector. I first go to the x, I go to the x, I go to the x, I go to the x, and then when I get there, I stop. Now the question is, do I need to go up or down to get to the head of the original vector? The answer is no. So if the answer is no, it means that there is no line that is going up, there is no line that is going down. Therefore, the y component is 0. So if you want to represent this vector in vector components, you will say the vector A is going to be this green vector. This green vector I've just drawn, let's call it AX, right? So this is going to be AX. It's always given by, so every vector is always having an X and a Y component. Okay, so how about the X component? Well, if you look at this line, the X component and the Y component are actually the same. It's fine then, let's just say, let's call it AX. AX is in the X direction. Okay. And then, what about AY? AY is 0. Right? You can put a direction if you want, it doesn't matter. To just represent anything, everything is going to go away anyway. So it turns out that vector A in the X and the Y direction, you can leave your answer like this, or you can leave your answer like this. Right? Where you know that the magnitude of A is going to be the same as the magnitude of X. Because if you look at this line, the green line and the red line, they have the same size. So this is the same thing. Right? So the vector AX is the same as the vector A. So what about when it's going up? Let me say I have a vector that is going up. Alright, so now I'm going to do the other way. So let me use the black one. Alright. Okay, this is the X direction and then this is the minus Y direction, which means that this is the 0. Again, I'll draw a line from 0. Try and get to the head of that vector using going the horizontal and vertical route. It turns out when I go vertical, I just get there. And there's no need for me to go to the right, there's no need for me to go to the left. Already that tells you that there is no X component because there is no vector that I can draw that gets me to the head whereby I must go to the right or go to the left in order for me to get to the head. Right? Just by drawing a line going up, I get to the head. So it's fine, it's enough. Which means that if I call this vector B, right, and the black line that I just drew, I'll call it BY in this case. It simply means that I can say vector B is going to be equals to whatever vector B in the X direction is, plus whatever vector by is. Now it turns out in the X, there's no vector. You can say X direction if you want. It's fine. It doesn't matter because it's nothing. So it doesn't matter. Whether you give it a negative or positive, it doesn't matter. There's no vector there. And then by, it's just a vector that is going up. I don't know the magnitude of by, but at least I know that it's going in the y direction. So you can leave it like this, or you can say a similar thing to what we said there, whereby we can say, well, then B, the vector B is just going to be by, whatever the magnitude of by is in the y direction. And it turns out again here that B is the same, the magnitude of B is the same as the magnitude of by. Alright, so if you wanted to find the magnitude of by, okay? Alright, so that's it. This is how you can actually break each and every component into vectors. And from here, and then you can actually just break any vector into components. And I think this is enough. So what I'll do in the next lecture is I'll make a practical example whereby we are adding more than 2 vectors. Maybe I'll start with 2 vectors and then I'll do 3 vectors afterwards. That's to show you how to then solve problems that are like this. Alright, see you guys in the next lecture, and then cheers.